got it. You got this figured out. You knew something wasn't smelling right. Test function right here is what we're given that when we start this loop, right? While continues to execute the loop until the test function returns false. That's how we would implement this, our own loop, if we simply wrap a while statement. We can also wrap a for statement, right? And this is going to blow your mind, but internally, when a compiler sees a for statement and a while statement, it can rewrite most for statements into while statements. Most for statements can be rewritten into while statements. We've had whole classes on this where we show it in assembly. But what you're doing is with the while statement, you take the test, you put it inside the loop, you update the loop, you check the test again, and you call return v. With a for statement, we assign a custom variable. We're testing right here, and then we put the modifier right over here. So let's go through what that would look like with a regular for loop. Now we probably have a couple of aha faces right now, right? Because now you're seeing what is essentially a for loop being rewritten in terms of a while loop. This is maybe the first time you've seen this. What is our normal update function for a while loop? 95% of while loops have the very same update function. It is, we say for I equals 0, I is less than 10, I plus plus. What is plus plus called?
Incrementer.
Incrementer, right? Incrementing. That is normally what you call in a for loop. The for loop is usually modified. It's usually changing to approach that condition when it stops using an incrementer or a decrementer 95% of the time. Update function here is incrementer. What do you get? V equals v plus 1. V plus plus. It is the same thing, right? We don't have to use incrementing. That's what this is showing you. But the de facto for a for loop is incrementing, and that's how that would look. Let I equals v. The test condition's right there. That could be equality, right, or equals 0. Let's say test function simply takes one variable and it tests whether or not it equals 0. Okay, we're setting I to v. The test function is making sure it's not equal to 0. And then the update function is decrementing. 10, 9, 8, 7, 6, until it gets to 0, and then it stops. That's how a for loop works. So there's our while loop. There's our for loop. Now, questions? We're going to move on, and then I'm going to blow up some heads, then we're going to eat some pizza. Then we're going to do it again.
Are you going to post this
somewhere? One person before you.
Oh.
Hit it.
Why are you setting I to V right there?
Yes.
Because I wanted to show a direct analogy with a for loop. There is no other reason to do it. You can keep I alone. In fact, we had a very early question, I forget who asked it, where I simply said, you don't always have to have everything for a for loop, right? You can leave some of those clauses empty. This would be an example where you could leave the clause empty. If you were feeding it the variable from the argument in the function, you could leave it empty. You could just say, if I replace let I equals v, right? And I simply say v everywhere, I could just have an exclamation point right here and that would work fine. That's exactly right. You don't have to have it. I just wanted people to see what they're normally used to seeing with the for loop. Okay, we had other questions.
Oh, are you going to post this presentation anywhere?
Yeah, I'm happy to do that. Yeah. Okay.
Could you also return the function itself after at the end of the statement?
Return the function?
As well. Yeah, return loop.
Yes. Okay. So the question is, how else can we do it? I think what you're asking is, can I do this with recursion? Is that right? Okay. So I told you we could do it two ways, one with iteration and one with recursion. I told you we're going to solve some of these problems thoroughly. Recursion. Good. You get a brownie point. That's the other way we can solve this, right? So here's with recursion, right? This is what this looks like. No one's head should explode. We're going to try to keep this simple. We're taking, again, all of the parameters in the same order. We're testing, right? If test function v, if that's true, we've satisfied the criteria for an iteration. I call body function with the value. I update the value. And then I call back loop with recursion. And I provided all of the same things. Why does that work? It works because I changed the value of v. I set v equals to update function with value. Now I can create a different variable, let v2 equals update function with the old v, and I can call it with loop with recursion v2. I can do that. If that blows your mind that I'm using the same variable internally, But each time I call this function with v, modified or not, that new function is going to get its own copy of v. Okay, does everyone see this? And I know not everyone understands it. Does anyone have any questions that they want to go over with it?
Okay.
Jason.
No, I'm back on the last one.
You're back on. You want me to
Question
go
about the other one? Yeah, with the omitting the variable. You said put an exclamation point in there on
Where?
the for loop.
here, this one?
Yeah.
Instead of let I equals B.
Instead of let I equals b, so you just put an exclamation point.
Semicolon.
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 I got you. Okay.
Yeah, semicolon. You can set different things in a for loop. You can exempt different things in a for loop. Internally, a for loop can be rewritten as a while loop in almost all contexts. There's very few where it can't. Yes.
You showed I think 4 or 5 ways to do the same problem. Is any one of them like a priori better, or it depends on what kind of function you're using or not?
I will have that conversation with you at the bar. Remember, there are some things that we simply exclude for brevity, and so we don't confuse people with needless minutia. By the way, today we're going to solve one of the times where I previously excluded something for brevity and for being useless minutia. We excluded the difference between a function as function, parameters, and then body with the fat arrow. Remember, it said it very early on there was a small difference, and then I said they're not explaining it, I'm not either, I'm not going to go down that rabbit hole. Today we're going down that rabbit hole, and it's kind of cool to see people that I previously denied that as being useless minutia, now we're covering it. And I like that because it means that we're advancing to a point where we can somewhat grasp those concepts. Unfortunately, to answer that question, there's got to be quite a few more concepts that we have to grasp. But yeah. So anyway, enjoy the pizza. I don't think I have another slide. I was literally just pitching this group. We did. I have some differences in opinion over the examples that this author is using. Does anyone here remember that absolutely crazy example we did? I think it was like the 3rd class where it was actually going to Greek phi to calculate statistic correlation.
Yeah, the squirrel.
Okay, a lot of this isn't quite that silly, but it's approaching it. We're going to decide how far we want to go into this based on how the class reacts to it, and I'm just going to feel it out. There's some stuff in this lesson that I think is extremely important to understand how to use and not important to understand how to write. There's a huge difference between someone who's going to be implementing a library that everyone will be using in JavaScript and someone who just simply wants to use a library in JavaScript. I don't know how far we're going to, I'm going to be able to hold the class as we get to the end of this. Did anyone here read this chapter before the class? Okay, this is a substantially better number, and I'm feeling way more positive than I was in the last class. So maybe we will get to it. We're going to try. Okay.
You might come.
You did what?
I read part of this quote.
Oh, he read the quote. There we go. An abstract data type is realized by writing a special kind of program, which defines the type in terms of the operations which can be performed on it. Okay. And that's certainly a book that's more complex than this one. All right, so we're defining method to start the chapter off. We're going to be talking about something called objects. Objects are object-oriented programming is another way to structure your program. Does anyone remember the 2 other forms? We've used 2 different words to describe methods in which you can structure your program.
Functional and object-oriented?
Functional was the last one. We're doing object-oriented today. There was one other one.
Procedure?
That's very close. Imperative, which includes procedures, right? Imperative programming means you're telling the computer what to do one after another. It's one step, then another step, then another step. You can do that by creating these things called procedures or functions that help you facilitate that. Jump to this block of code, this procedure. It's very direct. It's very easy. It's not very abstract. Functional programming and object-oriented programming are slightly more abstract. They're giving you ways to organize your thoughts and your programs, and they both have different disadvantages and advantages. We've seen some of the disadvantages with the functional programming. When we started it, everyone was like, yes, I understand that. We got to reduce, and half the people were like, I have no idea what you're doing, right? Object-oriented programming, I would say, is by and large substantially easier for people to understand. That's the advantage to it. There are other drawbacks. We're not going to touch on them now. We're going to go through how this looks. So the deal with object-oriented programming is it starts from a construct which we use every day, which is almost language and how we think, right? If you see something, it's a computer. You can do things to that computer. Close it, open it, throw it in the trash can. You have this object called a computer. You create methods that can tell you what that computer can do. We're defining methods from this book as simply being nothing more than properties that hold function values. That's certainly not the best definition of method, but that's the one we're working with here. And what they're saying is that if you have a property, right? If you have a property that has a function, it's a method. That's how this book is defining that. So you can see here we're creating an object, right? Rabbit is an object. Anything that looks like this, if you come from a different language, hashes, associative arrays, dictionaries, all of these types of things, JavaScript calls them objects, right? Now there's some shortcomings there because in other languages, dictionaries don't have methods, right? In JavaScript, your dictionary is your object and it has methods. So that's why I'm running with his definition rather than, laboring this point. But he creates this object called rabbit, and he says rabbit.speak equals, he's setting the property speak on the object rabbit to this function, right? This function is going to take a line and it's going to say console.log. It's going to put this stuff out, right? The rabbit says, and whatever you give it. Rabbit.speak, I am alive. The rabbit says, I am alive. That's so simple, I'm not even going to run it and show it to you. Usually a method needs to do something with the object it's called on. Now this is the real catch, right? Now this, for other languages, is one of the primary differences between a method and a function. A method is operating on an object. The object is storing what we call, everywhere else, state, right? If your object is a computer, there's all different things you're storing about it, right? If you're going to close and open it, you have to have something that represents the status of the lid. Is it closed? Is it open? Does it have power? All of those types of things, those attributes on that computer represent the state of it. And when you call those methods, they're modifying that state. That's the way we like to frame this outside of the book. And it may be more simple for you to think of it like that. So here he's defining a function called speak, and it takes a line, and it's saying console.log. He's printing this out to the terminal. This.type rabbit says line, right? Now here's the thing. That is going to work differently depending on what this is and depending on what the property type is, right? So let's take it and let's run it. This one, I'll start to run this. Code, make it a little bigger. Let's get out of that. Okay.
Why did you make a new directory?
Because I may dirty it up with some examples, and I'm
Okay.
not sure yet. Okay. So we've created this thing called speak, which takes a line, and then of course it outputs this. Now this is the catch, this.type, right? This is what he's wanting you to focus on. Now we're creating two objects with a type, right? And they have different types. Now under the terminology I just used, which you'll find in every other language, this is called state, right? The object state has type, and we're going to be reading from it. Now when I say here whiterabbit.speak, whiterabbit.speak is calling it on this white rabbit, and it's, if you see here, speak, this is a property. Let me explain that notation, right? Let me be very clear about that notation. When you define it like that, comma speak, it's the same thing as doing this, right? Just to be very clear about it. This is defining a property called speak that is pointing to the function speak, which I've defined up here. Does everyone see that? I just want to be very clear because this is a syntactic nicety. It's something new JavaScript came out with, and the JavaScript guys love it, right? Because it's shorter. But when you define something, you have a property on an object like that, you're essentially creating a key by the same name and pointing it to whatever that is, right? So we've created a function up here called speak, and we're defining an object, white rabbit, with the property speak that points to the function speak. Everyone following with me?
How come that the first one has to be in quotes then, the first speak?
It doesn't actually have to be in quotes because everything to the left-hand side of the colon in JavaScript will be presumed to be in quotes. It'll be presumed that it's an identifier. Does not require quotes. I just wanted to be clearer that that's a string, right? That's the property's name. So he's asking, why does this one have to be in quotes? It doesn't. This is the same too. Watch. Quotes, no quotes, or as the book wrote, this new syntax, all of those are the same. Right? So what we're doing is we're calling this method speak on this object white rabbit. That's what we did right here. We said white rabbit dot speak. Dot speak is going to look up the method, the property name speak, and it's going to call the function that was assigned to that property, which is right here. Does everyone understand the assignment of the function name to the property name? And then we're calling it. And then, well, you're going to see it does. That's what happens when you can't copy. Let's get back to where we were. Boop. And we get that, right? So white rabbit dot speak, the line, and it says, the white rabbit says, oh my ears and whiskers, how late is it getting, right? Because it's calling speak and it's saying this dot type is the white rabbit. That's where the type is, right? Because we're saying here, this dot type, I want you to realize this is getting replaced, right? This dot type is pointing to the object that it's called on. So here when we call it on white rabbit dot speak, type is white. You see that? This is the value of type. When we print it out here, this dot type, it gets replaced with white. It's property lookup. So we're calling white rabbit dot speak. That's calling this function up here. This function has this dot type. This is in reference to the object you call it on. So we're looking up, this is going to be in reference to this guy right here. That's what the whole value of this is. And we want the property type on it, which is white. So it says the white rabbit says, oh my ears and whiskers, how late is it getting? That's how object orientation works in JavaScript. You have a keyword called this. This points to the object of whatever the method is you're calling. Yes?
For the second part where you have speak coming in, I was just wondering how we're not using parentheses to call it as a function at all. So is it just looking back to see whatever speak is defined as and sort of dropping it in there?
Okay, you're talking about, let me make sure, you're talking about this speak right here.
Yes.
Okay, that speak isn't calling speak. It's defining a property called speak. And it's defining that property as being a link to the function. Right? You can think of it like that.
Right.
So when you're not calling the function, you don't use parentheses. That's a good question. You're only using parentheses when you call the function. If you define a property as the function, you don't use parentheses. And let me point that out. Let me show you how you can think of this, right? If anyone else is hung up on this, I'm going to show you this a different way. If I say let A equals, right, and then I say foo, and then I say here, let's make it a little simpler. Foo. Think of it like that, right? In this case, I have an object, A, and I have a property, foo. Now, if I call that function, I can use parentheses. And now it's going to say hello, right? But when I go up and I define it, if I do this, the function is totally different. If I look at A, I have a function, and if I look at B, I don't, right? And the reason for that is, this is essentially what you're asking. I want you to see the connection. When we defined this one here, right, we're adding the parentheses. Your question was, why didn't we have the parentheses? when we defined this guy here, right? And the reason for that is, if you have the parentheses, you're going to be calling it there.
Okay.
And what you want to do is you want to assign it. So if you call it, what you're going to get is the return value of speak. You see how speak isn't returning anything? That doesn't make any sense. Now, if speak did return something, you could do that, right?
What if speak wasn't a function? What if it was just another binding that you had earlier in the program?
Then it would be even easier. That would make even more sense because you don't ever have to worry about parentheses, right? So let me show you
Would it
that.
be written the same way?
It would be, yeah. So
Okay.
if I say this, like let's say let foo equals hello class. There we go. I have the string here, foo, hello class. Now if I say here let bar equals test 42, and then hello, or rather foo, like that. Now I've done just what you've shown, right?
Okay.
You wanted to know what it would be if it was. There we go. Jumped off the wrong string. If I had foo defined as just being a simple string,
Right.
here it's showing you just as a string, and here I'm defining the string, that property name, to just be a direct pointer to the variable, right? So now if I say bar.test, I get 42. If I say bar.foo, I get my string. So yeah. All right, going back, let's copy this back in here.
Can I point out one thing that I think is causing some confusion?
Sure.
So when he types function speak, he's declaring the function, but he's declaring it in the global namespace, the namespace that impacts everybody. When he's using this let white rabbit, I mean, could you go back to the example where you expand out the property? The speak, speak?
This?
No, when you were talking about the nicety and the syntactic sugaring and the collapsing of the actual
I
property.
don't know where I wrote that myself.
Yeah, we'll just check it again.
I don't know what do you want me to type? This?
Okay.
I don't know where I left off or what you're referring to exactly. I was just typing something.
That's where you had speak or speak, and quotes, colon, speak. So
Yeah,
that was the
and
same
someone
thing
asked you
by
about if
itself.
it's a string and, yeah.
Let A equal speak.
No.
Your previous line.
White rabbit, let white rabbit equals type
Okay.
white, speak, speak.
Okay.
Okay.
Yeah.
This is creating an entry into the map of white rabbit, the dictionary of white rabbit. That entry is called speak, all right? But this over here is a reference to the global function that he defined speak. He could also say let white rabbit type white, speak function, open parentheses, here's the block of stuff. That's more natural for some people who come from other languages where you define the function into the prototype.
And here's another way to think about it too. If we're hung up on that, that's quite fine. You could call the function speak function. Like you could pretend like this up here rather than being called speak with speak function, right? See where I'm defining this up at the very top? Let speak line. That could be called speak fn line, and I could be assigning that to the property speak. Everything would work the same, right? They don't have to have the same name. If they do, you can use this cute syntax shorthand that they're presenting with us. But they can be different, and as Ed said, you could totally have it anonymous, right? You could do something like this, console.log, and then, whatever. And then that'll also work, right? So if I want to call this here, let Evan rabbit, now I have my own function speak, right? And I can say Evan rabbit.speak. And Evan rabbit says whatever, right? So you're assigning the property name speak to the function. That's the mapping that Edwin's talking about. If I come over here and I wanted to say here, we come up and da-da-da-da. That also works, right? So you don't have to have the same name. You can assign an anonymous function to it. You can do all of that kind of stuff. The mapping's what's important. Okay, now I'm gonna get back onto what the book says. So when we look at the book, let's actually clear this stuff out. I'm gonna jump back into it, clear out all the code we wrote, and we're gonna get back to this. Dun, dun, dun. Okay, so now when we say hungryrabbit.speak, right, and he says, I could use a carrot right now, what's going to happen here when we call hungryrabbit.speak? Anyone want to give this a shot?
Run, and it'll inject the IDV carrot right now into the line parameter.
So this is going to get injected up here into line?
Right.
Okay, so then essentially we're going to have this when we call speak, right? The this.type. Now what else is going to happen? We're going to call this function, right? We're going to be, because we're passing line down here. This was the value of line, right? Speak, whatever was in here gets put over here. So this is the same thing. Now what does this.type get into? Hungryrabbit.type, right? And what is that? Hungry, right? So then it's going to simply be the hungry rabbit says, I could use this carrot right now. And that's exactly what it says right down here. The hungry rabbit says, I could use a carrot right now. Except single quotes, because that's how the book did it. And I just cut them out. Okay, so that's exactly right. That's all that's happening here. Okay, moving on. So you can also, you have this method, right, of where you're calling the function, this method, on the object, and it's reading this property, right? The keyword this, it's reading that to determine what the type is. Now they're showing you here, you can use .call, right? And .call allows you to provide the value for this. So what is this? Let's step back a little bit here. This is magic under the hood, right? It's presented to you to make things look simple, and how it works is somewhat simple too, as long as you understand it. The book is going to try to explain to you how this works in JavaScript. Let's create our own this, just for shits and giggles, and I'll show you how it works. If I had something here, the book didn't quite show it like this, and we do something like let my this equals that, right? Or foo bar, right? That's my this. And then I create a function, right? And the function's first argument is my this, and then line. And then I said something like console.log. We'll do it the same way. Hello. Okay. Now I can call speak with my this, and then I can say and it's essentially the same thing. You have in JavaScript, right, you have a special variable called this. And essentially, every time you call a method, the object that you've called that method on is given the value this. And it's passed implicitly under the hood, and you don't see it.
This, I guess, your second my this, the T should be capitalized, so it's not under, down one line below.
No, he's dereferencing type off of his my this.
And it should be foo.
And it should be foo.
That's right, okay. So let's go back here, and that's exactly right. This should be foo. Good catch. I should read it right after I run it. Hello bar, this is a test. So what we're doing in my example is I'm passing it the value of my this, and then I'm calling my this dot foo right here. My this I'm setting up here, right here is where I set it. And I have a value, a key, foo, and a value bar. When I call my this.foo here, it's going to look this up and print out bar. This is an explicit method of passing another object, right, the my this object, which has the properties and values on it. When you call a method in JavaScript, it's implicitly passing your object, right? And that's going to have whatever stuff you put on it. So we had this thing, we called it state before, right? And I told you the state is what the methods operate on. Well, up here, your state is being declared with this, my this. I'm declaring an object and I'm storing stuff in it. Now when I call speak, I'm providing it what has that state in my this. JavaScript does the same thing under the hood for every method call. That's what makes a method different from a function. The methods receive a custom value for this that points to the object that you define the method on. Right? So I just want you to understand that the voodoo is because you don't see it. In some languages, you see it just like we wrote it. The first value you pass to the function is the argument, is the function, is the object itself. You see that in some languages. In JavaScript, when you call the method, you don't see it. This just magically is a pointer to the object. Yes?
Is the magic of this in JavaScript a new thing?
No, JavaScript actually got this right from very early on. This was one of the few things that JavaScript did right. So this is just how JavaScript did object-oriented programming.
Is this still defined in your example?
Is this?
This?
Yes, it is. We're not going to go into that just yet, but it is. So let's leave that one aside. Minutia, which we won't go into. Any other questions? Okay. So who wants to sum up what we just did here? Someone, can anyone wrap this up in like 30 words? Okay, I'm going to try to wrap it up one more time because that's it, right? We're defining an object. That object is my this. We're passing it to this function speak. Speak is receiving the object as the first argument, and then it's reading into that to determine it. So rather than having this magical this, we've created our own. Okay, so when we call this function .call, all we're doing here is a new object is going to get assigned to this. That's it. So when we have speak, we pass in our own object here because we've defined my this up at the top. JavaScript hides that all from you. So when you call speak.call, you can provide it any object, and it'll get that for this. So let's, and by the way, I realize how absolutely horrible it sounds in English to say you'll get that for this. And that's probably because it's hard to describe this without using the word this. Okay.
Don't use the word.
Yeah.
They'll get it.
Yeah.
Some languages use name. Some languages use self as well.
That's exactly right.
Yeah, that's
So
like
that's
Python, right?
Yeah.
Perl.
Perl.
Yeah,
Python.
Perl, Python, they're both basically, they implement them the same way, right? So yes, that's exactly right.
Just talking, if you have a function, you can pass as arguments that can be values, objects, and functions. Does that exhaust all the possibilities?
You can pass anything that's a primitive, right? So you can pass primitives or you can pass objects of any kind. And that's it. So your primitives in JavaScript are going to be things like arrays, objects, null, all of that kind of stuff. Numbers, yeah. Anyway.
Functions.
Yeah, let's.
Functions.
Okay. So I want to show you this here. I want to show you this here. Oh my God, the puns are just not going to stop. Okay. We're going to drop this again, and I'm going to look at this now. This, I can't quit it. Okay. We're going to look at call, speak.call. And I want to pay attention to this. Speak.call, right? We've defined speak up here again. I've reset it to just showing you the code the book uses. The function speak takes a line, and it's looking at this special magic variable, this. We're using speak.call now, but we're calling it on Hungry Rabbit, right? That's going to provide Hungry Rabbit as this. Hungry Rabbit's type is hungry. So it's going to say, the Hungry Rabbit says Bert. Now you could also do Hungry Rabbit dot speak. And those two things are the same. And that's the important thing to take from this, right? In this one, we say hungryrabbit.speak, which is the method the method speak on the object hungry rabbit. In the other one, we just call the method itself speak. Speak is defined in a fashion that it expects this. So how are you going to set this? You set this in JavaScript by using the special method called. Right? So speak is a function. It's going to call speak up at the top, except it's going to set this to being hungry rabbit. Yes?
So if speak wasn't expecting this, if you remove that, or if you remove this dot type from speak, and then you passed it hungry rabbit,
Nothing would happen because it's simply not checking the property.
okay.
That's right. And in fact, if you're not using this in the function, you can actually set that first argument to null, and then no one can ever use this in the function. So if you want to be sure no one else is checking this when they define that function, you can always call it with null.
Where do you tell speak to expect this then?
Oh, right here. It's this is
Okay,
where it's
so that-
expecting this. So this is an implicit argument to all methods. Every time you define a method, it gets an explicit argument called this, right? An implicit argument, I'm sorry. It gets an implicit argument called this, right? That's not something you see, it's magic under the hood. I just exposed to you the magic by creating a my_this, and I showed you how it worked. That's it, though. I mean, it's one of those types of things. It's nice to see how it works. I showed you how it works, but JavaScript is going to do all that for you. If you call the method, and it's going to get a special argument called this, which is the object. If you want to define a method and you want to look at your object, just check the argument this. It just happens. All right. Does anyone else, I know that not everyone got this. Does anyone have a question that they can phrase to ask? Because that's always the problem with these types of questions. All right, I'm moving on then.
Here
So,
it is.
what's up?
I said, here it is.
Here,
The
oh.
difference is coming up here.
Yeah. Okay. So Dan asked me the question I think earlier on, what is the difference between the fat arrow method of defining a function and the function method of defining a function? Let's rephrase. We have this, we could say let foo equals bar, right? That's a function called foo, takes an argument, bar, and then it's going to output console.log baz. It's going to do that. You could also do this, function foo, bar, console.log, baz, right? I showed you both of these early on. Of course, it's going to give me that error. But if I didn't already define foo, I wouldn't get that error. You would see them both being different, right? Let's just define it as foo2. What is the difference between foo and foo2? I always wanted to dodge this, and it came up like 5 or 6 times after I tried to dodge it the first time, obviously. Okay, the difference between the top one and the bottom one is this one, foo2, is going to get that special argument this, right? And that is going to be in reference to something. The top one doesn't touch it. So when you have this argument this, right? I told you inside of the method call, you get a special argument called this. If something in the fat arrow calls it, like if I say let foo equals, and then I say console.log this. Man, you're going to give me identifier fun all day today. If I do something like this inside, because this is defined with a fat arrow, the syntax up at the top, this doesn't get overridden. This is going to be in reference to object, right? With the fat arrow method, this is in reference to the object it's called on. But if I do it with the function, then it doesn't get the object it's called on because it's going to get a local copy of this. And I'm not sure if we go through an example in this or not. Since each function... No, he doesn't actually go into any examples of it. I'm trying to think of whether or not I want to go... Let's leave it at that for now. This is different for the fat arrow and the function syntax. In the function syntax, you're always guaranteed to get your own copy of this, right? With the fat arrow syntax, you always get essentially what is the this for the outside scope. And that's kind of the difference. So without understanding this, you can't hit both of them. I'll see if we can use this later on in a method. Okay, so we are, guess that code's not mad. Yeah, let's skip that. We're going to go on to the prototypes. So has anyone here worked in a different object-oriented language or a different language with object orientation? Edwin, a couple of people here.
Python.
Python, there we go. Okay, so most object-oriented languages have a very clear concept of a class, right? And essentially a class is what you use to create the object. And a class has, inside of it, you can have parent classes, right? Superclasses. The superclass is essentially what you're doing when you're saying this is overriding other things. You have essentially a notion above, which is more generic, animal, and then you're defining a subclass, dog. Dog overwrites some of the things about an animal because it's more specific. Maybe it adds more things to the animal, right? When you work with object orientation, you're always constantly categorizing things, saying how can I eliminate redundant code? So dog may be a subclass of animal, which may be a subclass of mammals, which may be a subclass of living things. And each different time you go down, that child can define more things to become more specific to its needs without overriding things that are generic that it may otherwise use. JavaScript does this too with this concept called prototypes, and we're going to see that here in a second. Prototypes allow you to essentially define things in which you will use to mold future objects. So in the same sense that you have animal and dog, you can define an animal prototype, right? And then dog can be based on that prototype. It's a different method of doing it, but you can achieve very similar results. So let's look here. We're defining an object called empty. Okay. So here we define an object called empty, and it's got nothing in it, and we say console log empty toString, and what we get is function toString, right? And then this is just a comment, right? So if you look here, the syntax highlighting makes that very clear. This is a comment, and I copied and pasted everything. The console log empty toString on the bottom is returning object. So what he's showing you is somewhere in this, you have on empty, which has nothing, you have a property called toString. Now, how does an empty class that has nothing in it have a property called toString? That's the question that you should be thinking about. And the reason is empty, though it has nothing in itself, it is modeled off of something else that defines a toString property, right? So when you create an object, you automatically, by default, you are building something from a prototype, usually of something called object in JavaScript. So all things tend to descend from this object. An object.prototype has something called toString, which allows you to define how that thing gets stringified, right? So he's showing you here, there's this object.getPrototype of, and that is actually going to tell you what that prototype is. So if we come down here and we say object.getPrototype of, you'll see that the prototype of an empty object is, I'm trying to see where he's going with this. So what is the prototype of that empty object? It's the great ancestral blah, blah, blah. Okay. He's showing you here that you can call this thing called object.getPrototype of, you can give it something like empty, and you can test that against something else. So there's object.prototype itself. These two things are the same, and you're showing you that the prototype of the empty object is the same as object.prototype. They all descend, right? I don't think that that's at all a good way to show this, but let me think if I can think of a better way to show this. If I take something like here, object.getPrototypeOf, and I think of something that's slightly more clever, like a number, I think that should say number. That's a good example, right? The number 5 descends from a prototype called number.
How come it's number 0 just because you number?
I have no idea why it's saying that, but that's just the way it gets. There's a method. We just discovered the method, in fact, called toString. And toString can be defined for different things, and the way that number defines it, it prints that out, right? But the point here is that everything, every primitive in JavaScript has a prototype. Most of them eventually get back to object, but they don't start off there. So if I do something like, if I want to pull, let's do an array, right? Object.getPrototypeOf, an array. That's really, it should say array, but you're getting this. So you notice when you do object.getPrototypeOf and the array, you get an array. When you do object.prototypeOf an object, you get an object. That explains right there why when you call something like, if I say let A equals an empty object, let B equals an array, and I told you early on if you forget the method, you can mash on tab. Remember? That was the lesson. If I mash on tab with A, which is an array, which is an object, I get this stuff. Notice how many things there are, right? There's not many. If I mash on tab with B, am I going to get more or less?
More.
I'm going to get more, right? And the reason is because all arrays are objects with more things defined. So when you define an array, you get something that descends from array.prototype, which itself descends from object.prototype, right? I think that's a slightly clearer example than just this. But the bottom line is that these prototypes essentially define the relationship with what you're creating and something else. And that something else can define basic schema, methods, properties that you descend from, that you have. Okay. Get prototype of object.prototype. This is showing you here that not everything has a prototype, right? Object.prototype is the parent-most thing. Nothing, object.prototype doesn't descend from anything. At that level, it's literally defined inside of the JavaScript engine. So object.getPrototype of object prototype returns null. And that means that there is nothing further, right? There's nothing above it. Okay. This should start to make sense to you if you've ever defined a subclass-superclass relationship. That should be like your, if you come from a different language, that should be how you're kind of framing this. And it's very easy to follow that. Okay, so there's one other thing, right? So far we've seen arrays have this prototype that looks like an empty array. That's how it gets stringified. Objects have a prototype that looks like an empty string. We talked about different things you can pass into methods. One of the things we can pass in is a function. Functions also have a different prototype. So if I say let C equals, and then I give it a function, now C is a function. C dot object dot get prototype of C gives me function, right? So functions also have different prototypes. So if I do C and then I mash on tab, I'm going to get different things that I didn't have with object, right? So A is the object, B is the array, C is the function. If I call any of those and I mash on tab, I'm going to get a different set of things that it can expand on. If I look at A, I have, which is the object, I have just this stuff. And if I look at C, I have this stuff. Now let's look at one that's there, that's not on object, right? We have call. We just saw call. What does call do? It provides the value for this. C is the function that I define. This C descends from function.prototype, which defines call, right? The object that I defined does not descend from function.prototype. Because it doesn't descend from function.prototype, you don't have .call. It wouldn't make sense. What would .call mean to an object? Nothing, because an object isn't code, and it doesn't have a this that can be replaced. The function is what gets the this. That functionality is implemented in function.prototype.call. Okay. If anyone has any questions on this, feel free to raise your hand. I know it's a lot to take in. I don't know if I'm missing anyone or losing anyone on it. We're looking here at let proto rabbit, but now we're going to start using these prototypes. So here what we've done is we've defined this thing called proto rabbit, which is an object with inside of it a property called speak. Speak is defined with this function. Now we just talked about some syntactic shorthands of JavaScript. We showed how if you just give it a name, it's going to map a property name to whatever that value is. If it's a variable, we showed that. If it's a function, we showed that. Here we're getting a property key of speak, and the value is this function right here. It's the very same thing as if I said let b equals, and then I said speak equals the speak property, and then line. Let's look at this. So these two things here, these two things are very similar. In this one, the one that's highlighted, we're defining this property called speak to be a function which takes a line and calls this console.log. In this one up here, we're doing the same thing. I just want you to understand the syntax that's happening. Speak is the key, and the key is being defined as this function here, which takes a line and it does this. These two things are the same. They're just different syntaxes. But now we're introducing the syntax. So, proto rabbit. Proto rabbit, there you go. There's your definition. There's the other one we created. Oh, no. My proto. And there's your definition. This is just showing you that proto rabbit and speak look the same. So with this proto rabbit, he says he's going to create a killer rabbit, right? Killer rabbit is object.create proto rabbit. Now what that's going to do under the hood is when you create a killer rabbit, the prototype on killer rabbit is going to be proto rabbit up here. So let's take it and let's do that. Killer rabbit equals object.create proto rabbit. Now killer rabbit.type equals killer, and killer rabbit.speak. The killer rabbit says scree. Now let's go up here. We can see this is where we define this. This is our proto, right? It's right up here. Let's look at this. Console.log, this.type, rabbit says line. We're defining the killer rabbit type to be killer, and we're calling it with scree, which is the line. And that's how it's outputting. The killer rabbit says scree. Does everyone kind of understand what's going on here? What's important to see is that the method for this, killerrabbit.speak, right, is not being defined on killer rabbit. It's coming from the prototype, object.create proto rabbit. Proto rabbit has speak. We're creating that connection between proto rabbit and killer rabbit, and proto rabbit has speak. Yes?
Is this kind of like inheritance from other languages, or is it different?
Kind of like inheritance, yeah. It's a lot. All right. So, classes. Classes are a new thing to JavaScript. Let's take a look at it. So we're creating something here, a function called makeRabbit. And makeRabbit is essentially going to say it's going to create us a new rabbit with the prototype of proto-rabbit, right? So with this, let's look at this. This is kind of cool. I like this. We're creating a function, and that function can be called to create new rabbits. Those rabbits descend from proto-rabbit. We've already established, does anyone remember the name of the function that proto-rabbit has? Speak, right? And proto-rabbit speak is looking for a property named what?
Line.
Type. Type, exactly. So when we call makeRabbit and we give it a type, it's actually setting the type not on the proto-rabbit, but on the rabbit you're creating. While at the same time, speak is received from proto-rabbit. So proto-rabbit defines speak, but the rabbit you're creating is going to have this type. So when you call it rabbit.speak, it's going to see this type, and then it's going to say, I don't have a speak. Go up to my prototype. And the node's going to go up to the prototype and say proto-rabbit.speak. So when we say make rabbit Evan, right? Let er equals make rabbit Evan. Now we should be able to go er.speak hello, and it's going to say the Evan rabbit says hello. Rabbit type is defined only for Evan. When I call speak, it's coming from proto-rabbit. Proto-rabbit defines speak. Speak is wanting to see rabbit.type. Rabbit.type is defined on the rabbit that I just created, Evan, right here. So that's how that all meshes together. The superclass, if you will, proto-rabbit, expects there to be a type defined on those subclasses. If you come from a different, object land place. Okay. So another way they can do that. Let's go ahead and take this and paste that there. Okay. So we are defining a function called rabbit, which takes a type, and it sets this.type equals type. This is very close to what we just did. So we just defined something called make rabbit, which takes a type, and then it created something based on proto rabbit, and it set the new rabbit type to type, and it returned rabbit. Now we're defining a function rabbit, and it uses this. Notice the one up here does not use this. It used rabbit, right? You remember when I showed you the example with my_this? Does anyone remember the example where I showed you how this can be implemented by yourself using my_this? And I tried to show you this is how this works. This is this guy's my_this. This is where he's introducing this concept now. So rabbit here is being defined as the object prototype, but the rabbit.type, this is essentially the same thing in the next example, is just simply saying this.type. And that's what he's doing. That's the difference. The difference is in the last one we were being explicit, that we were setting properties on an object. And on this one we're using this magical this, which is pointing to the object you call it on. Right? So when we say rabbit.prototype.speak, we're defining the prototype for this function, rabbit. Right? So we're defining a function, rabbit, and we're setting on that function the prototype. We're defining a prototype function called speak. So if I take it and I say new rabbit here, weird rabbit doesn't have a speak. This is an object, but there's no speak. That's because we didn't define speak on the object. In the last example, we defined speak on proto-rabbit, and then we created it with object.create proto-rabbit. We come up here, revert to original code. We used object.create proto-rabbit, but if we look down here, we're not doing that. We're using new rabbit, and we're actually defining speak on the prototype of it. Right? So these are just different ways of doing it. You can create yourself a proto-object and define your different methods on it, speak, or you can create yourself a function and define things on its prototype. Right? All functions have a default prototype object. You can define things on that default prototype object. Right? So that's what we're doing here. So speak is coming in here. This is where it comes in, rabbit.prototype.speak. And now we can actually say weird rabbit.speak hello, and we get the weird rabbit says hello. So we're showing you in both of these examples, speak is being defined on the prototype. One of them explicitly in an object, which we're using that object as the prototype. And in the other one, we're using a function and we're defining speak on that's prototype. If you do that, you define it on the function's prototype, you have to use this keyword new to create an object. That's what we're doing. New takes a function, calls the function, sets the this property, sets the whole thing up as an object. The other method does it in a different fashion. It's the more traditional method, right? Okay. I'm not sure where I'm losing anyone. Does anyone have any questions about this? Object-oriented JavaScript is a lot of fun, isn't it? There's a lot of different ways to do these objects. You can do them with functions. You can do them with your traditional prototypes and those regular object syntax with object.getPrototype and object.create with the prototype. Yeah.
Which method do you prefer to use?
I prefer the method that's not this one, the functional one. No, I prefer the one at the top.
One at the top?
This is the one that I prefer. This is the only one that I use.
One function?
Yeah.
Because if you do it the other way, each time you add the prototype, you always have to write dot prototype.
It's not about how long it is. It's just about style. Right? So at one point there was a difference in the way that they would compile these things, but that doesn't make any difference anymore. This is pretty much all done. It's largely a stylistic critique. This method is prototypal. Jeez, I don't even know. Ed, is it prototypal? I've never heard that word, but that sounds like how you would pronounce
Sounds like
it. This is called prototypal code in my parlance. And the other method is more like a traditional object-oriented code. If you come from Java or you come from C++, you're going to be more used to seeing it with the new syntax, right? This class syntax, and then calling new, and then the object name, and all that other stuff. Okay. And we're going to see more of it as we go along. This is also totally new, by the way. All like here. So JavaScript classes and constructor functions with a prototype property. That is how they work, and until 2015, that's how you had to write them. Now we have this new syntax. So yeah, this is just, the thing about this is like, they're teaching you all of the different options, but none of these things are giving you any additional power. It's just different syntax, right? That's it. So yeah, you're learning all of this stuff, and it's likely to confuse you, but they're just different ways to skin the same cat. So here we're defining class rabbit, and class rabbit takes a constructor, which takes the type. If you come from a language that has constructors, what constructors do is when you ask for a new object, they get called by default. And the constructors take all of the arguments that you give to new. They are the ones that set all of those properties. Right? Let's go up here and let's see how we did it previously. When we see this function rabbit, we had to set this.type. So we're getting a type, and we're calling it with this.type. If you use function, that's how it's done. Now there's a different syntax. The syntax is class. In the last one you had function, and this one you have class. All classes are functions. The difference is, when you define a function, you have to define the arguments that you use to construct the object. When you have a class, you define a constructor that takes the arguments that you use to construct the object. And if that sounds like a really pissant way to spend your day learning difference between, I'm inclined to agree that this is what the book is doing, and I want to make sure everyone understands it. Does anyone have any questions about it? There's really nothing more to this. It's just, if you define a function, the arguments get passed to the function. If you define a class, the arguments get passed to the constructor. And the same thing happens under the hood.
So the same thing happens under
the hood.
Under the hood.
That's right. Yeah. I just don't want anyone to think that there's extra special magic, and if you use class, you're doing something better for the computer or whatever. It's really just syntax. There's a difference in that if you define a function, it may have nothing to do with an object. Functions can be pure. They can have input and push out output, and then they have no object, no this, nothing. If you define a class, everyone knows you're going to be using this. It communicates something extra potentially to the programmer, but the computer doesn't do anything different with it. It's just new whiz-bang syntax. Okay. That's it.
Well, if you knew for certain that you didn't need an extra special this, you'd want to use a pure function because it would be more efficient.
It wouldn't be more efficient. The same shit
Would not.
would not be. It would just be clearer that you don't want to use this. Functions, who asked the question, what is this set to in the function? Is that you? That was, you asked that question, right? Someone asked me the question. They said, when we have a function, we call it, right? With call, what happens if we don't use call? What is this set to? I forget who it was. Someone asked me the question. Was it you?
Maybe.
Okay, someone asked me the question. If you have a function, look, let me show you this. If you have function, this is dumb, and we call this function console.log this, there is a this that gets sent to it, right? So if I say this is dumb, you see a bunch of crap there. I'm not going to go into what all of that stuff is, but what I want you to see is that under the hood, nothing special happens. When you call a function, this is set to a global object, right? It's still there. So there's not like a special optimization or anything cool.
That was my question.
Yes, there you go. OK. Anyways, and some people are going to pick up this stuff, and they're going to figure it out, and they're going to say, well, wait, what in the hell is this set to in a regular function if you don't use call? If call is defined on the prototype of all functions, right, and every function has call, then what does it do on functions that aren't methods? It seems like a very logical question. It's a great question. But yes, I'm just using that now to show you that there's no special optimizations in place. OK, no special things happening in the back end. So here, they're also showing you here that when we defined it up here, we said class rabbit. We defined this kind of like this specific class in the most traditional object-oriented sense, or syntax that looks like that. Here, you can also do it like this. You can define your own object like this. Object, let object equals new class, get word, hello world. Now I'm going to blow your mind. It's the very same thing as if you did this. OK, these two things are the same. There's no difference. This just gets back to the point about syntax, right? In class, we're defining this method, getWord, which returns hello. This is a nice way of saying, like, a newer way of doing it, I guess, or something of that sort. This is the other way. The other way just says object. There's your traditional object. It has this property called getWord, which is a function that returns hello. So just so you can see, I'm just trying to expose different syntaxes so it all comes together. That really, we're just spending time talking about syntax. OK, overriding derived properties. Rabbit.prototype.teeth equals small. Yeah, I just want to make sure I'm... OK, let's take this. Let's paste it, because I think that we're starting off with this stuff again. Oh. OK. Now what we're going to do is we're going to come down here and say, OK, so now let's go through this. We have this class up here called rabbit, and I've showed you there's 1,000 different ways we can create it. But now what we're doing is we're saying rabbit.prototype.teeth equals small. This is not defining it on the class, it's defining it on the class's prototype. So when you call killerrabbit.teeth, right, killerrabbit is an instance of this rabbit class. When we call rabbit.prototype.teeth equals small, we're setting it on the parent of rabbit. So when we call console log killerrabbit.teeth, it's going to print out the same thing, small. Even though we did it after the fact. The reason is simple. The property gets defined here. Didn't exist beforehand. Now when we look that property up, killerrabbit.teeth, it's going to go through that prototype chain to find that teeth. And it's not going to give up until it gets to the very top and doesn't find it. It's going to find it the second it gets to rabbit.prototype. OK. Shelly?
Yeah.
Yes.
So speak would also be considered a prototype method?
That's exactly right. Yes. No, speak is actually not a prototype method. Speak is on rabbit. So we have rabbit. Rabbit.speak would be there. There's rabbit.prototype.speak would be... Let me think of a better way to say this. Hold on, I want to be careful with the words because I don't want to confuse. I don't want to. speak is not. I don't. Yes, speak is definitely. That is right. So when you use the class constructor like this, speak is getting defined on the prototype of it. That's right. So when you call rabbit.prototype.speak, that's exactly right. The speak is there, right? Because it's going to be on every instance of rabbit. So you want every instance of rabbit to inherit from the same prototype that has speak on it, because you're only defining it in one place. So that's exactly right. I misspoke on that one. Good call. Anyone confused about that? So if you look up here, let me see if I can try to say that a different way. If we look up here, we did this with the function way. When we did function, we defined this as being function rabbit, right? This is essentially a trick when you do class around the constructor. When we did it this way, we quite clearly said rabbit.prototype.speak, right? It's right here. When we defined it in the class way, like I said, it's nothing more than a different syntax. Speak is still on the prototype. So when we defined it up here, it was very explicit, rabbit.prototype.speak. When we do it on the class, it's a little bit more confusing, but Shelley is right. It's being defined on rabbit.prototype.speak, because this is just a different syntax for the same thing. Okay, questions? Okay. Overriding derived properties. So you have now killer rabbit and black rabbit, and what we're doing here is we've created rabbit.prototype.teeth is small, but we can actually override that for each and every instance of that rabbit.prototype. So we have killer rabbit, and that just has a type of killer, right? And then we have where we set this rabbit.prototype, that has teeth equals small. So when I call here console.log killerrabbit.teeth, you see small. But you can also go here, what they're doing is they're saying killerrabbit.teeth equals long, sharp, and bloody. And now when I call killerrabbit.teeth, I get long, sharp, and bloody. So we have on the rabbit.prototype, the teeth are small. That's still there, but we've overridden it. And for killerrabbit.teeth, we've defined them like this. So when I call console.log with killerrabbit.teeth, I'm going to get this guy right here. And that's showing you, we asked the question before, is this like object-oriented inheritance? Yes. This is where you see that, those attributes there. In your subclasses and object orientation, you can override things that are defined in the parent. Okay. Does everyone kind of see how that overriding thing works? Are we getting that? So we can extend on things the parent defines, and we can override them. So let's talk about that really quick. When we did the whole mash on tab thing, and I showed you that array descends from object and it adds to it, array can also define different things that object.prototype did differently. So one of those examples is toString. All of those things have different stringification rules. And when we look at that, I think that's actually what we're going to go to in this example. Or coming up, we're going to start to look and see how we can override that for each different sub-prototype or whatever. I don't know the right word for that. In object orientation, it's very simple. When we define something that uses a prototype of an array or of an object, we can define different stringification rules. So when you want to see them as strings, different things happen. Okay. So let's take a look here. Okay, this is good. This is easy. We can all relax our brains. This next part is a walk in the park. We have this thing called maps, right? If we look here at let ages, this is an object, and it equals this stuff right here, right? So this is very simple. We have 3 key value pairs. But that's not all that it has, right? It has a lot more than that, and we saw that in the beginning. Remember when we did the example with empty? And then we showed you that empty had a toString property. And everyone said, where did that come from? And we started to demystify it. And I said, well, there's a prototype thing. That prototype thing is object.prototype. Object.prototype defines toString. That's where you're getting it from. OK, well, if we use ages, ages has 3 keys and values, but it also defends from object.prototype, so it gets a lot of other crap. What they're showing you here is that there's a thing called map, right? And map is substantially easier. It's implemented differently. It is faster. And if I do that, of course, they're going to use the same name, which is going to do that to me. If I use that, let ages equals new map like this, now you can see that I have something that is not an object in the traditional sense. When I did it the other way, I defined it like this. Let ages equals, and we did the curly braces. Now we're using this special thing called map. And here's the catch. Map doesn't descend in the same way from object.prototype. So if I do ages.tab, I get this stuff, right? Because map's prototype provides much more useful things, and it allows for a whole different implementation. So if you're just using key value pairs, the right way to do that in JavaScript, though many people don't, is to use this thing called map, right? Because it has substantially less stuff than objects do. So we can see here that we get, what type of methods do we get? We get clear, we get entries, we get keys. There is no clear on an object. If I say let foo equals A42, I can't call foo.clear. It doesn't exist. But I do have ages.clear. That does exist. Because we're defining ages now as a map. They're just showing you another. This is actually like the addendum to how to do key values in JavaScript. OK. Anyone have questions on that? Yeah.
Are those mapped one-to-one?
Yes. Yeah, you can't. Every key maps to one value. And because they're not goofy, like in JavaScript, objects can act as arrays, and they can do all kinds of really weird and horrible things. Maps are substantially simplified. Yes?
I guess whenever we make a map, can we still define a function within? Like in your key value pair, could we say chorus and then comma and define a function?
I think so. I don't see, like, maps are so that I would say that my experience with maps, because very few libraries are actually using them, is somewhat not where it should be. And that's partly because we tend to run a lot of our code in the browser in JavaScript, and not every browser is supporting these, you know? So they're like new whiz-bangy things that are, I think they came out 2 or 3 years ago. So let's see here. Let's try that. Let my map equals new map. And then we're going to say mymap.set. By the way, what was your name? You said you had JavaScript experience? Yeah. Can you call values that are functions in maps?
In map?
Yeah. Is this going to work? You have any idea? He doesn't know either. So I do JavaScript professionally. I have no idea whether or not this is going to work. Let's give it a shot. I think it's going to work now, because now it's telling me that it's actually got it stored, right? So get.foo, yeah. OK, yes, it does work. You can store different values that are not strings in maps. But the key has got to be a string. OK, very good. Good question. Console log. So we're seeing here this new thing called has-own property. If you have, so now the question comes up, OK, well, we have crap on our object that we didn't define, like toString. How do we know what that stuff is? And how can we detect where it's coming from? We have this thing called has-own property. So if I do, let's go back to let empty equals the empty object. If I do empty.has-own property, and then I say toString, I get false. Even though empty.toString is there. And the reason for that is that the toString property doesn't pass this test. So every object that descends from object.prototype, everything that descends from object.prototype has own property, right? And that method allows you to test to see whether or not that argument you're giving it comes from the object or from the prototype chain as it goes up. Okay, so if you want to know whether or not killer rabbit has kill or whether or not it's defined in prototype rabbit, you can say killer rabbit dot has own property kill. And if it says false, it's defined in proto rabbit. And if it says true, it's defined in that. Okay, we're seeing heads nod.
What if it's not defined in either?
What if it's not defined in either? It's got to be. It's literally has own property. If it's not, if you have the property and it's not defined in the current object, then it's false. Doesn't matter how many prototypes it has to go up. If you want to know where it's at in that prototype chain, then you can crawl it yourself and say object.prototype has own property. False, and you go object.prototype.prototype, it has own property. If it says false, you just keep going until you get to object.property. You would have to write something like that. So that's if you want to know where it's defined, right? Because you can have, an object can have a prototype that's an object, which has a prototype that's an object, and so on and so forth. You can go on for a while. You can chain these things together. Okay. Polymorphism. By the way, how's time? We're at 8:30.
8:30.
Yeah, let's
wrap it up.
Yeah.
I was kind of surprised. I thought JavaScript has a type of polymorphism. I had heard from somebody that JavaScript was not a complete object-oriented language because it didn't have polymorphism. But
so it's weird. There's this concept of polymorphism and there's this concept of duck typing. And there's not really a clear distinction about where the line is drawn. Maybe Ed can opine on where he thinks the line is drawn. And I'd probably go with his definition. But the reality is that I would call JavaScript more of duck typing than polymorphism, wherever that line is.
okay.
So you want to hit that one up?
Sure. The major difference between duck typing and polymorphism is that duck typing impacts the typing system, whereas polymorphism is late binding.
Is what?
Late binding.
Okay, don't lose everyone. Please. Yeah, give it a shot. Yeah.
So I'll try to explain in a way that everyone can follow along.
Just I mean,
Let's say you got something in a
duck type,
variable.
You need to define that.
If it looks like a duck.
Yeah.
So let's say you got a variable, okay? And we'll just call this variable A because we have absolutely no idea what's in it. And you decide that you want to call a function on A, which in JavaScript means that you dereference the parameter, the property that the function is stored under. So we've been talking about speak a lot. So speak. All right. Whatever is bound inside of A's map, whatever function this is going to get called. Okay? And based on your types that you have set up, if this is possibly typed in a type hierarchy or typed in such a way that there's a number of variables that are very similar to A that could be replaced with possibly different functions, you'll just basically find the right function for whatever is stored in A. Okay? So that late binding of taking this name here and finding the implementation, whatever the implementation happens to be, is what makes polymorphism happen. Polymorphism itself basically means that you can use like one interface to your object, like one front door, and your object itself comes up with a different behavior based off of which copy of the object you're running. Okay, so they are all the same at the interface, but their implementations of how they behave might be different. Now, in an object-oriented system, you have a thing called a type, and the type is how you classify and organize your objects. And we've talked about parent objects and child objects and stuff like that, or superclasses and subclasses. Some typing systems are very strict. JavaScript's typing system it actually has one. It claims it doesn't, but it does have one, and it's very, very loose. So in JavaScript, if this entry exists inside its dictionary, then it assumes it matched. But other object systems, you can actually prototype the structure of the interfaces without specifying anything else. For example, who has heard of Java's interfaces? Java's interfaces are nothing except a small file that says anything of this type has to have these methods. Okay? And so this is a strongly typed system to where if you say, let's say it's a car type, okay? So if you say that, like, you know, a Toyota is a type of car, then it won't compile in Java unless you provide the A, B, and C functions at all. Whereas JavaScript, basically, it says that if the sub exists at the time that you're resolving and running, then it'll work.
It's like an ad hoc dispatching, or
yeah, it is sort of like, because you can